Okay, welcome back. Dr. Lindner here. We are still continuing with muscle physiology. When we mention the term contraction, remember the term contraction means generating tension within a muscle. And we can generate tension in a variety of ways. One is a concentric contraction, that is A. B is eccentric contraction. And then C is an isometric contraction. Now, what's the difference between these three? Okay, when we look at A, concentric, the starting position is here. I'm going to put number 1 as the starting position, and number 2 is the ending position. So the book right here at the bottom at the starting position is the weight. It could be a dumbbell, right? It could be a weight. It could be your groceries, whatever it is. And you're going from 1 to 2. You're going up in this direction. So that means you're moving this resistance or this load against gravity in a controlled manner. And the biceps muscle, let's change the color here to red. So here is the biceps. And the biceps origin is here, and the insertion is down here. When the origin and the insertion of the muscle approximate one another, meaning they move closer together, that is a concentric contraction. When we go from number 1 to number 2 in the middle picture, when you start at the top and you're moving down in this direction, lowering that weight, lowering the book, lowering the dumbbell, you're now lowering it in the same direction that gravity is taking it, which is down, but we have to do it in a slow, controlled manner. So when you're lowering something at a pace slower than that of which gravity wants to take it, that's an eccentric contraction. And what's happening is that the origin and the insertion of the biceps in this particular picture here, same muscle, is moving further apart. When the origin and insertion are moving further apart, that's eccentric. So the key there is in the word eccentric is E for elongate, because the muscle is elongating. Okay? Now in the last picture on the right, isometric, it means same length, same meters, right? Isometric. This is when they're holding the book or the weight straight out in front of them. There is contraction here, and I'm sure there's contraction here and contraction at the wrist muscles. But they're holding it statically. There's no change in the joint angle. That's isometric. Okay, so those are the three different types of contraction: concentric, eccentric, and isometric. Now, we can use eccentrics and concentrics when we talk about neuromuscular re-education, meaning, let's say someone comes to you and they have poor posture, they have rounded shoulders and the head moving forward, from texting all day or looking down at a computer screen or something, right? So they have this rounded forward type of posture. You could elongate these anterior muscles. Let me erase this here. So what we can do is, if the person had those rounded shoulders, let's see if I can choose, let's use red again. The pecs, the pectoralis major that's here, can be elongated eccentrically, and then the rhomboids back here and the middle trapezius can be strengthened concentrically. So the pecs could be elongated eccentrically with eccentric type of contractions. We call them negative contractions, like doing negatives. And then the rhomboids on the posterior side and the middle traps can be strengthened concentrically. Sometimes we call the negative the eccentric contraction, and the concentric contraction is known as the positive contraction, right? Because you're slowing the movement down at a pace slower than gravity wants to take it with an eccentric contraction. And with a concentric, it's a fast ballistic movement during concentrics. So we use this all the time to elongate muscles and to shorten and strengthen them when we need to start modifying posture. So concentric is when the muscle tension exceeds the resistance or the load and the muscle shortens. We said that's when the origin and the insertion move closer together. We said it's called the positive contraction or the acceleratory phase or acceleration contraction. Whereas eccentric with the E is when the muscle elongates. It's when the origin and the insertion move further away from one another. It's the negative contraction or the deceleration. And isometric, iso means same length. The tension never exceeds the resistance, so there's really no change in the joint angle. Now these terms here, origin, insertion, action, synergist, antagonist, innervation, these are kind of important. When we talk about origins and insertions, origins are typically the part of the muscle that is attaching to the bone, right? Muscles attached to bones by way of tendons. So one of those tendons is going to be an origin, and the other tendon is going to be an insertion. The one that's usually more proximal and usually stationary or not moving is the origin. The tendinous attachment that's usually more distal and usually the part that is moving is the insertion. So in the case when we were saying biceps, origin is here, insertion is here, this part stays still, and since it attaches to the forearm, it's the forearm that's moving. Okay, that's the movable part. When we talk about agonist, antagonist, these are opposites. Agonist is the main muscle that's going to provide movement, and then the antagonist is just really the muscle that's going to do the opposite. So in this case here, if we were talking about the biceps, well, what's going to oppose it? If the biceps are flexing the elbow, what's on the opposite side here? That extends the elbow. Well, that would be the triceps, T for triceps. So the biceps and triceps are going to be antagonistic to one another. The agonist for elbow flexion would be the biceps. If I said, what's the agonist for elbow extension, you would say the triceps. If I said the triceps extend the elbow, what is the antagonistic muscle to it? You would then say the biceps brachii. If I were to say to you the biceps brachii is a main elbow flexor, can you name a synergistic muscle to it? Synergistic means, can you name another muscle that basically does the same thing that's going to assist it? And there are several muscles that flex the elbow. Okay, the biceps brachii is a biggie. The brachioradialis is another. And the brachialis. So those are three muscles that basically do the same thing. All right, what do we mean by innervation? Every muscle has a nerve supply, right? Innerve. See the word innerve, innervation. When we talk about muscles of the upper extremity, this is everything from the shoulder down to the fingertips. Those are going to come, the nerves that go to those muscles are going to come from the neck, from the levels C5 to T1. Okay, C5 nerve root, C6 nerve root, C7 nerve root, C8 nerve root, and the T1 nerve root. Yes, there's only 7 cervical vertebrae, but there are 8 cervical nerve roots. Those nerve roots come from what's called a brachial plexus. That's from the neck. Now, muscles of the lower extremity, these are muscles that are from the gluteus maximus or from the rump, right, or the buttocks, all the way down to the toes. It's going to come from the lumbar plexus and the sacral plexus. Nerves must go to a muscle to make them contract. If you cut the nerve, the muscle dies. The more a nerve is stimulated, the more a muscle grows. If the nerve is not stimulated, then the muscle weakens. Okay, and there's ways of measuring that. So those are important terms. When we come back, we'll talk about some of the microscopic parts of skeletal muscle.